Hello? Schon verstanden? Can you hear me? Everybody can hear me, great. So if we just wait, let's say, half a minute. Lauter? Guck mal, die sagen hinten noch lauter. Frank, lauter? All right. Good, ladies, gentlemen, dear guests, partners I see, colleagues I see, old colleagues, new colleagues. All right, let's start. I'm proud today to present our latest innovations. But before I really start, I would like to take you on a journey. A technical journey. A journey that already began in the 60s. It is the journey of the MBR technology. In the 60s, so long ago, my parents, they listened to the Beatles. All you need is love. Probably most of you, they do not remember. It's very long ago, but this was really the birth of the MBR technology. At this time, the first MBR process was developed. It was the so-called side stream MBR process. And this was introduced by a Canadian company called Dor Oliver. Over the next 2 decades, in the 70s and in the 80s, nothing really happened. There was not really a success to penetrate into the market with MBR. But this fully changed in 1989. Question to you, what changed? What changed in 1989? The whole world changed in 1989. Any ideas? Someone remember 1989? Whoa. Someone is saying the wall, and that's right. 1989, the wall fall. And Germany after that was reunited. This is 35 years ago. Why I'm saying this, why I'm mentioning this here? Because in the same year, the submerged MBR configuration was introduced. It was introduced by a scientist, Katsuro Yamamoto, and this was really the changer. This was an amazing development, and due to him, the whole success story of MBR has started. So what he did, what is a submerged membrane MBR system? Everybody knows it, everybody using it, but let me summarize what great idea he had. He had this idea to place into a biological system directly the membranes in. And using the aeration system for the oxygen transfer needed for the biological system, but also using it for air scoring, for cleaning the membrane during a filtration process. And this combination was a success, because with an air scoring during filtration, you have these flexible membranes always moving, and you have been able to control the cake layer growth, and you have been able to operate in high solid concentrations in membrane system. This combination of processes was really a technology breakthrough and the beginning of an incredible water technology adoption story. So what happened? 1996. Someone remember this year? Some football fans here probably. Someone said Germany won. Exactly, we have been UEFA champion. And probably we will repeat this year, right?
No, probably, for sure.
For sure, that's what I want to hear. Yes, we will do so. In 1 month we will start. Why I mentioned this here? Coming back to the introduction of the submerged MBR configuration, already 6 years later, polymeric MBR were a proven technology. What does it mean? Immediately after the announcement of this design, there were extensive R&D programs. They have started all over the world, very successful in pilotings and demonstrations. Also in the early 90s, pioneering companies like Xenon and Kubota launched their first products, hollow fiber membranes and flat sheet membranes, and they have used their products already in first customer projects. So in the mid of, sorry for that. So in the mid of the 90s, there was no doubt anymore that this technology works, and it became a proven technology. Then, almost 10 years later, in the mid of the 2000s, MBR were considered as commercial technology. They have reached the early majority, references running over a couple of years, several suppliers available, a lot of data, a lot of knowledge were shared, so that the technology was first time specified in projects. Consultants recognized this technology as a treatment solution, and plant designers used already this technology all over the world. So what you can see here was one of the first large projects specified in Germany. This is the Nordkanal project, started in 2004 with a capacity of 45,000 cubic meter per day, and that time the largest plant in Europe. 2014, some ideas. What was the highlight there?
Germany born again.
Germany born again, yes. We have some football fans here. See, what a highlight for all. We became FIFA champion, finally. Took a long time and takes decades. Also that time, the MBR technology has been finally recognized as fully mature, fully adopted. A really great journey of this technology. That time, the largest plant in the world was a 250,000 cubic meter per day plant in operation in China. And this was the plant Kunming in Beijing, using Beijing original water hollow fiber membranes. So why I'm saying you all these long and great success story of polymeric membranes in MBR. What happened with the ceramics? So actually with the ceramics, the same journey started, only 16 years later. In 2016, in 2005, 16 years after the submerged polymeric MBR concept was introduced, the first alumina MBR demonstration plant was installed. This was on a golf course close to Saarbrücken. It was actually my master thesis, a very great plant, the first plant using ceramic membranes in MBR. It then, almost a decade later, reached a level that alumina membranes have been considered as proven MBR membranes. What you can see here is a picture of a plant in Jurong in Singapore where alumina membranes have been used from made in China. Already in 2009, PUB, Singapore utility, which is very well known as being an early adopter for new technologies, has piloted alumina membranes and has specified them in Jurong for the first time. Sorry, 2021. So just a few years ago, 7 years after the success of Huron, aluminum membrane were specified in large size projects, and they are considered right now by consulting firms and by system engineers and plant designers. So the alumina MBR became also in the early maturity stage, and they are really recognized to being an alternative membrane for MBR solutions. What you see here on the picture is a friend of mine, and I was just searching. He is not yet here. Niva, he's the manager of Maidenschar, and he did really a great job with his team. He secured an MBR project, the largest one so far, using ceramic flat membranes in MBR. It's an 98,000 cubic meter per day plant in Singapore, a job together with the POB. So MBR today, where we are. The MBR is a unicorn technology using polymeric membranes, hollow fiber, as well as flat sheet. More than 10,000 installations all over the world, a lot of suppliers available, and over the last 2 or 3 decades established a market of more than $3 billion. Aluminum membranes. Aluminum membranes are a proven alternative membrane, and they are seen as a discontinuous MBR innovation. And they're the successor of polymeric membranes for sure. From this big market, ceramic MBRs covering approximately 1% only. But they already have approximately 100 installations in 25 countries, and also there are all over the world aluminum membrane suppliers available. What are the challenges of MBR? Over the last decades, all the teething problems, a lot of operational challenges have been already resolved with polymeric membranes, but also with aluminum membranes. Just some examples: sludge clogging. Sludge clogging in the module has been resolved with a better pre-treatment, using a better screening system. Also, the high air storing demand has been optimized with new innovative aeration systems. But still, in the operation, there are challenges, especially when it comes to the selection of the right membrane. On one side, and just remember the idea of a submerged system, you want to have a movable membrane where you use the aeration, the air storing, in order to remove and to control the sludge growth and to remove permanently the sludge. But on the other side, these movable polymeric membranes, they are breakable. So I think every one of you has already heard about fiber breakages. So then for under challenging conditions, the operator probably decides for flat membrane. But flat membranes, polymeric flat membranes, they are very limited in backwashing. Actually, they are not backwashable. So you will probably decide again for the polymeric membrane. Both polymeric membranes are limited in cleaning. In MBR, you typically decide for going with a PVDF membrane. Why? Because they have the highest resistance against chlorine, and chlorine is very often used for cleaning. So with these both already, you have to decide either for the hollow fiber membrane, or for the flat membrane. And then you have on the other side this new alternative membrane, a robust aluminum membrane, but on the other side so far, and this was main reason of not maximum performing, you have a rigid design. You are not able to have the benefits of an air storing and the moving of a plate in the MBR system. So what's the choice? You have currently 3 choices. Either you go with the hollow fiber polymeric membrane, or you take the benefits of a flat sheet hollow fiber membranes, or you go with an aluminum membrane. That's the dilemma of choice for the user, either or. But from today, we are making it very, very simple. We are combining all products in one. We will have an unbreakable membrane, always cleanable and movable. And here it is, the FLEXX-CAP. We are reinventing the MBR with FLEXX-CAP. So, let me show you how this works. You can see here the ceramic membrane encased with new end caps, and these end caps are flexible. We designed this flexible end cap in a way that we create engineered micro movements due to the air scoring. So we found a way to bring a rigid membrane to a controlled shaking membrane by using the air scoring. With this movement, sludge detection is possible during the filtration. We are reducing the thickness of the boundary layer, hence we are reducing the cake layer formation. Yes, we will increase with this design the MBR performance. How? We will have longer filtration cycles, we will have less backwash requirements, we have a lower fouling, and we can achieve higher flux rates. And it's patented, for sure. This product, this technology is only available at Cerafiltec. Okay, but right now, just let's not wait longer. Let's just show you the ceramic. So, here it is, produced in Saarbrücken with a flexible end cap. It's not breakable, it's always cleanable, and it's movable. Okay. So, I think that's it already. Thanks everyone. I see a lot of people right now here. Thank you very much for being here today. And please stay. Let's celebrate right now the FLEXX-CAP, our new latest innovation with us. Take a closer look to the technology, talk with our expert team, speak with them, and talk about new MBR opportunities. Thank you very much.
Do we ask questions?
To the expert teams immediately, come. Thank you. And right now, come, we will celebrate.
How are you doing?
Mach aus.